Okay. Hey there, just going to check everything is set up and the sound's coming through okay before we get started on this question. Okay. Hey there. Okay, looks good. We got a few seconds delay. All right, any questions as I go through this, just pop them into the chat and I'll do my best to keep an eye on that. So we've got our three complex numbers that I put on the end of, our three merit questions I put on the end of yesterday's video. So we have this complex numbers question. Now, this one is best if you can wrap your head around the geometry of complex numbers and modulus and things like that. You can do this one algebraically and then work out what the equation means. And when I say algebraically, I mean by putting in z equals x plus iy. I'm not going to use that method for this because it's much faster if you can understand the geometry. So let's go with that. So this bit here, let me just get a thicker pen. If we can rewrite this as z minus something entirely, then that gives us a circle where the bit that's inside the bracket there is the centre of our circle. So z minus 3 plus 4i, by putting it all into the bracket, that's what it's going to look like. So from that, this means that the 3 plus 4i is the middle of our circle. So there's 3 plus 4i just here. And z minus that means that z is a distance away from that middle of the circle. The modulus tells us it's a set distance away from there and that set distance is 2. So we're going to draw a circle with radius 2 because that's what was given in the question. Oh, I'm going to just see if I can make that drawing just a little bit better. Here we go. So it's super clear. This is a circle with radius 2. And you want to make sure there's no ambiguity in the way that you've drawn something. If you're really terrible at drawing, write out at the side, circle radius 2, centre 3 plus 4i, to make it super clear to your examiner what it is that you are meaning there. Okay, now the second part of this, and you do need both parts together to get the merit here. What is the maximum value of the real part of z? So z can be anywhere on this circle. And we want to pick z that has the real part of it being the largest it could possibly be. The real axis being on the x-axis here. So we want the largest number to the right of that axis. So that would be, if we popped z just here, that's where we'd get the largest possible real value. And that largest possible value is 5. So I'm just going to, I feel like I haven't written enough. So the real z max is 5. You could just write down 5. It'll be fine. Okay, so moving on to differentiation. Just let me get that set up. Okay. We've got this situation with an airplane and we have a cost function for it. And we are asked to work out the minimum of the hourly cost. So we need to differentiate and set it equal to 0 to find the stationary point, and in this case that stationary point will be a minimum. Okay, so I'm going to rewrite the function here so it's all in powers. So that'll be to the -1. Then we will differentiate with respect to v. So dc by dv is 4. Now, if we bring the -1 down, we're going to have a million v and then reduce the power by 1. We want to set that equal to 0. So that means it's 1 million over v squared is equal to 0. So 1 million over v squared equals 4. Or if we bring the v squared up to this side and bring the 4 down to this side, then we're looking at, let me just get to the right place here. I'm going to do 3 divided by 4 and then square root our answer. So v equals 500. Now it's tempting to stop there, but we're not quite finished. We've found when it happens, and that's when v is equal to 500 kilometers per hour, but we actually want the value of that minimum cost. Okay, so find the minimum cost itself, which means we need to take that 500 and put it back into our cost equation. So the minimum cost when v is 500 is 4 times 500 plus 1 million over 500. So we have 4 times 500 plus 1, 2, 3, 4, 5, 6 divided by 500, 4,000. And I'm just going to go check the units being used here. Dollars per hour. Units were not required there. I'm just checking the mark scheme now. If you just put 4,000, then you would get the merit point there. Okay, on to integration. And we've got a differential equation where we need to separate the variables. So we'll bring 2y up to the left-hand side, leave it with the dy. And then we've got 3 root x, so I'm going to write that as x to the half, and bring the dx up over this side. Now integrate both of those. So we get y squared, and then we'd do the 2 divided by 2, so that's just a 1. On the right-hand side, we increase that power by 1, we'll get 3 over 2. Divide by the new power means we're times by 2 over 3. So dividing by 3 over 2 is the same as timesing by 2 over 3, which leaves us with a 2. And then plus c. And I'm just checking as I go that I'm not making any mistakes. Okay, so next is to use the information that we've got to work out the value of the c. Okay, so we have when y is 5, x is 4, so we can pop those in like this, and we will get, if we do 25 minus 2 times 4 to the power of 3 over 2, and I'm being very careful with my brackets here to make sure that all goes in correctly, that will give us the value of c. So c equals 9. Now find the value of y when x equals 9. Okay, so last portion of this, when x equals 9, y squared equals 2, 9 to the 3 over 2 plus 9, because that's what we worked out c to be. Okay, so 9 to the power of 3 over 2 is 27. We're going to times that by 2 and add on 9. We get 63. So y is equal to the square root of 63. Okay, just checking there, that's all good. If you got to this line here, that's where the achieved was sitting. and then all the way through to finding the square root of 63 is where you get your merit. Okay, that one that felt like a really quick one today. Perhaps we just got lucky with some easy questions there. But yeah, we've done that in about 10 minutes. 3 merit questions in 10 minutes. And that's actually something to bear in mind for when you go into the exams, is look through the options that you have for trying out the different questions, and be strategic about which ones you try first, because you could get through some of those easier types of ones quite quickly and then give the excellences a go. All right, anybody that wants to stick around and see the questions that I will do for tomorrow, I'm going to just go and pop those in now. So we'll go back to the complex numbers, and I'll just go and grab the next one along. Okay, so this will be our complex numbers question for tomorrow. If you want to take a go at that before I come back and do that one with you, that's probably the best way to approach these things. Here comes the differentiation one. Let's pop that just there. And finally, the integration one. Let me grab that one. Here we go. So we'll pop that one in. Yeah, there we are. So if you want to go back and pause on those questions and give those a go, and I will come back and do those work solutions tomorrow. Not sure of the time just yet, but perhaps around 7 o'clock. I know Infinity Plus One has got a calc. I don't know if that's tomorrow, but I don't want to get in the way. I think his calc might be the day after, for his calc help desk. He starts at 8, so I'm thinking I'll go at 7, and then you've got time to hop over to Infinity Plus One if he is doing something that's of use for you. Okay, and that is me done for this evening.